Hello, and welcome to the second discussion on Team 3's MSIM applied project entitled DIY Residential Security and Monitoring, a transformational model involving technological and process refinement. Team 3 consists of Melvin Davies, David Moore, and Krishnan Narayanan. The residential security segment is experiencing significant growth due to the adoption of next-generation electronic security solutions, increasing burglary rates, and attractive insurance policies for residents with security systems. Industry revenues are expected to increase annually by 2.5%, reaching $18.9 billion in 2017. With the adoption of Internet of Things, remote monitoring devices will drive incrementally high-margin revenues. Applying the macro framework, Pestle reveals a solid industry with few operating risks. Positive disproportional impacts exist to exploit for profitability. Economic factors for the residential security industry are very attractive, as well as the social, cultural, demographic and technology factors that can be profitably exploited. Using the micro framework of Michael Porter's 5 forces analysis reveals attractive opportunities for continued profitability. In particular, the threat of substitutes reveals that for the value proposition of 24/7 365 security, no real alternatives exist. The bargaining power of buyers reveals general consumer dissatisfaction with price point, multi-year contracts, and inability of system mobility. With that in mind, MSIM Team 3 has chosen ADT to recommend a transformational business and technology model sustaining ADT's leader position. ADT Business Canvas reveals a solid foundation for the introduction of strategic alternatives. In particular, maintaining ADT's value proposition as the bundle of system-integrated alarm solution and home automation hardware. As well, ADT's cost structure is cost-driven with competitive elements of value-driven approaches. ADT's revenue streams are solid, resulting from asset and subscription fees. ADT's strengths, weaknesses, opportunities, and threats analysis reveals significant strengths in value proposition, brand, and leadership. ADT's weaknesses are in areas of competitive product offerings, customer contract terms, attrition and customer acquisition costs. As well, a noticeable lack of big data integration into new product offerings is important to note. Opportunities for exploitation for ADT include the integration of new technologies into the product mix and expansion into temporary residential security markets. Team 3's recommendation is that ADT undertake a project to facilitate customer purchase of wireless portable alarm systems and home automation components from the ADT website. Complete the financial transaction for a monthly subscription model. Complete the home installation without or with a minimum of ADT assistance. Provision onto the ADT monitoring systems using home internet. And activate self-monitoring with ADT monitoring backup. This strategic transformative business technology project will fulfill the requirements of enhancing competitive advantage, positively impacting key metrics, reducing costs, and increasing long-term profitability. The current business process is labor-intensive to acquire and support customers. Through automation and process refinement, reduction in 3 dedicated labor cost centers can be achieved with reductions in headcount and associated cost savings of facilities closures. The future state will be accomplished through an e-commerce portal, eliminating the need for sales agents and on-site alarm design visits. Alarm kits specialized for DIY residential installation will be sent directly to the customer, eliminating need for field install and repair service technicians. Activation of alarm system will be provisioned over customer's internet connection, and big data information from alarm usage will be relayed for future advanced analytics research. Finally, upon an alarm event, the customer is the first line of triage, reducing need for monitoring agents. Synergies will be realized in the integration of the web-based sales portal, refined order fulfillment, and customer internet-based provisioning. As well, additional synergies will be realized in the integration of customer and smart device monitoring. All of these will enable cost reductions in operations, overhead, and headcount. ADT's market share will expand significantly with the new model. ADT's brand and existing penetration is well positioned to facilitate the introduction of the proposed model, expecting at least a 2% growth year over year. The implementation of the new model proposal within ADT will take approximately 3 years. The project will be managed by a dedicated program management office consisting of governance personnel from every functionally impacted department. Each project will be executed by the standard ADT project management waterfall methodologies, except when projects are more efficiently executed with other methodologies such as Agile for software development. All work streams will be governed by the PMO with periodic quality gateways to ensuring alignment with scope, time, budget, and quality. ADT uses 4 primary KPIs to manage its existing operations: average customer acquisition costs, average revenue per customer, operating costs, and customer retention. Incorporating these KPIs to measure success of the new model are appropriate and will enable like comparisons to the existing operations. As illustrated here, the approach utilized the standard balanced scorecard model, incorporated the ADT primary KPIs, and included KPIs that reflect the strategic focus of the new model. An illustration of the proposed recommendation is displayed here. The approach will be leveraged with existing ADT assets where possible for cost containment. Newly purchased technology will be approached with the characteristics of extensibility, scalability, and integratability. As illustrated here, customer physically configures the alarm system in residence and activates the ADT alarm base station, creating a subnet in the existing residential internet network. The customer signs into the ADT provisioning website and makes the connection between base station and ADT's big data stack, provisioning, monitoring server clusters, and 3G 4G backup systems. The provisioning database operates as a subdomain name service matching customer's base station with the dynamic DNS and monitoring connection. The monitoring systems execute the monitoring functions by issuing alarms for any device status change on an ARM base station in the sub-DNS database. Software acquisition, development, or mixtures of both will be needed to ensure connectivity between the new model's hardware, the provisioning process, monitoring, and big data collection. Listed here are the major software components, including the open source Hadoop and related big data software. ADT's development teams will need to modify the source code for all software to ensure backwards compatibility as well as future integration. ADT will leverage existing software wherever possible to contain project costs. The majority of the project is software-driven. It will be critical during the quality and assurance testing that all scenarios are tested, retested, and examined for possible software points of failure. It is also important that all software be load tested for performance and system behavior by simulating interactions between application components. Finally, with critical software vendors, partnering or arranging for custom support may be needed to ensure internal teams gain the desired support skills or ensuring availability of support from vendors. Repurposing existing hardware or procurement of additional hardware infrastructure will also be needed to ensure interoperability and connectivity between the new model's hardware, the provisioning process, monitoring, and big data collection. Illustrated here is the listing of primary hardware needs, whether purchased or possibly leveraged with existing assets, and a summary of its needed functional or operational needs. Similar to software requirements, ADT's development teams will need to modify the operational code for all hardware to ensure backwards compatibility as well as future integration. ADT will leverage existing back-end hardware wherever possible to contain project costs. All project hardware will be rigorously load tested with software to ensure operability under high demand and loads. Again, it will be critical during the quality and assurance testing that all scenarios are tested, retested, and examined for possible hardware points of failure. Finally, with critical hardware vendors, partnering or arranging for custom support may be needed to ensure internal teams gain or reinforce desired support skills or ensuring availability of support from vendors. Essentially, ADT is one massive network. Customers' alarm networks, either existing traditional or in this next generation technology recommendation, are sub-networks that attach to the master network and communicate with centralized monitoring stations. Thus, The most critical part of the proposed new alarm systems functioning correctly on the ADT system is the ability to integrate new discrete components into the interconnected system and operationally monitor in order to fulfill the requirements of alarm monitoring contracts. Displayed here is a list of the primary integration points for the new alarm monitoring system, its supporting systems, and summaries of needed integration characteristics. Similar to software and hardware requirements, ADT's development teams will need to modify the operational code to ensure backwards compatibility as well as future integration. All project integration points will be rigorously load tested with software and hardware to ensure operability under high demand and loads. Finally, it will be critical during the quality and assurance testing that all scenarios are tested, retested, and examined for possible integration points of failure. The adoption of the new processes and technology from employees is key to the launch of the new model and will enhance positive customer perceptions. The dynamics of the new model necessitate not only new training, but also reinforcement of old processes, as all teams will need to operate in parallel. Business processes, workflows, hardware, software, integration, issue escalation, and remediation approaches must be developed, disseminated, and reinforced in a comprehensive manner and integrated easily into daily tasks. The process and technology training matrix details key functional areas of the new model, roles, intersecting cross-functional areas, and brief descriptions of new processes. Training will be delivered either by classroom to incoming agents or by the ADT learning module system, enabling pre-recorded audio and video modules to be reviewed by personnel. Overall, the implementation will cost approximately $41 million over a 3-year period, breaking even early on in normal operations. Displayed here are the assumptions used for key revenue and cost calculations. Generally stable economic conditions with a cost of capital at 10% are used for forecasts. Overall efficiency is included in all forecasts include the gradual reduction in sales, field, and customer care agents due to reduced operational needs, a closure of one facility due to reduction in headcount, and repurposing or disposition of property, plant and equipment. Concerning revenue forecasts, a slight cannibalization is expected with revenue shifting towards the new model. However, the impact on overall profitability will be offset with the volume and market expansion into the untapped transitory residential markets. Revenue estimates are generated upon market adoption, driving per unit revenues. Markets were broken down to residential owned and transitory residential for separate market adoption approaches, and a 2% attrition rate was included in all forecasts. The cost approach is based on the fixed costs and a ramp-up of the variable costs based on market adoption. All fixed and variable costs are stated as of 2015 market. All labor costs have been adjusted to include tax burden, benefits, and overhead. All other incremental costs are an estimate based upon historical operating costs outside the scope of the project analysis. The following financial forecasts include most likely with a 5% market adoption, pessimistic with a 2% market adoption, and optimistic scenario with a 7% market adoption for comparison purposes. The model was forecasted for 13 years, the first 3 years as the initiation of the project and the remainder as an initial forecast. Internal rates of return, net profit, and net present value were calculated for each scenario. All 3 scenarios point to overall profitability, with project break-even occurring in year 2 for the most likely and pessimistic and year 1 for the optimistic scenario. Internal rates of return are all high and positive for all scenarios, as well as net present value of dollars spent over the project costs. All assumptions remaining constant. The net income per customer shows positive growth, indicating efficient usage of investment and cost mitigations. The conclusion is that, given any market adoption, the benefits from this project will yield significant profits and return to stockholders. Post-implementation timeliness will be measured against market adoption of the new model, with a general 2% year-over-year growth expectation and viewed within the lens of total market and focused industry analysis. Effectiveness post-implementation results will be through analysis and comparisons of the balanced scorecard KPIs actual results with internal refinement on processes that directly connect with KPI drivers. Finally, the worst-case scenario should be considered in the unlikely event that market adoption does not gain traction within 3 years after execution. It would be prudent to discontinue operations. However, several viable options afterward include possible expansion into dedicated retail spaces. In conclusion, MSIM Team 3 hopes that this follow-up presentation has solidified your interest in the recommendation. The team looks forward to the approval. Thank you for your time.